Nice as well.
All right, matching. Oh, this is the fun stuff. Matching antennas of feed lines, phasing lines, and power dividers. Boy, that one threw me too. I don't remember that on my test. The Wilkinson divider. You know what a Wilkinson divider is?
I read what it was and I forgot. I knew
It's a power splitter.
I knew it's something that I'm not going to be doing.
Yeah, it's kind of microwave stuff. All right. So you need to match your antenna to your feed line with some sort of matching network. Use one of these antenna tuners, which doesn't tune anything.
Which symbol is that on your absolute values?
Reflection.
You know what that is? That's gamma.
Okay.
You know why they call it a gamma match? It looks like that.
Yeah, it's got that little part sticking out.
Yeah.
And if it's both sides, then it's a delta. So that does make sense, gamma.
That's a gamma.
I guess I've got a delta match on my 2 meter. My 2 meter antenna I bought yesterday.
Yeah. Yeah. That would be a delta. If they're not parallel, it's a delta.
And I actually made a gamma match one time.
Yeah, that's the funky one with the capacitor.
It was for loops. So and my capacitor was a compression capacitor. I just took aluminum plastic that was a foot wide and made a 9-degree turn at the top on one side and then a hinge on the other side. So I would do my compression that way.
Supposedly, I guess the main use is to feed a Yagi directly with 50 ohm coax to use the gamma. Or they claim to use a grounded tower as an antenna. That one, but I guess it works. Okay, so
There's trade.
huh? Trade-off?
That's a big trade-off, isn't it?
Well, I don't know. I guess if Viren can load up a rain gutter, no reason why you couldn't load up a tower that's grounded.
Yeah, I've seen that stuff about loading up towers.
Yeah, I guess that means you could you can connect your antenna directly to the tower,
Yeah.
have a real high radio. Okay. Reflection coefficient is the ratio of the amplitude of a reflected wave to the incident wave, which is the transmitted wave. So it's really forward and reverse voltage. It's related to SWR with that formula that's hard to read because I can't do real mathematical symbols. But it's 1 plus the magnitude of the reflection coefficient divided by 1 minus the magnitude of the reflection coefficient. And that will give you the SWR. The reflection coefficient itself is just the ratio of the reflected, which is the V minus, to the incident, which is the V plus. So what parameter describes the interactions at a load end of a mismatched transmission line?
Reflection.
All right, delta, there you go. It allows you to match a high impedance transmission line to a lower impedance antenna. So as you spread your feed point on the antenna, where instead of it being 35 ohms or something, the more you spread it out, you could get it up to 50 or 75, whatever you want. And it's balanced. So you know, connect it to the driven element in 2 spots, but not directly on the center or the ends. It's some fraction of a wavelength apart. And they call it a delta because it looks like a Greek delta. Most of these, I guess, almost all the mathematical symbols are some Greek letter, either a capital or a lowercase. There's a typical delta match, and the ratio of the A to B for the triangle determines the effective impedance. So in this case, they're showing matching a 600 ohm line to a half wave. They don't show a split in the center, but assume that may be a dipole, so you'd be 70 ohms or less there.
So I think the delta match is on a wire like that isn't separated in the middle, solid.
Yeah, solid.
Solid halfway.
Oh,
length.
okay.
So unlike a normal dipole where you split it, so you could do that on a dipole, don't put a insulator in the center.
Okay,
Solid half
actually, yes, because I do remember, I think I saw that with a Yagi or something where you didn't have to have separate elements, you just have a straight wire, just like the,
So if all you had
Directors.
was 600 ohm line, then you already had that, don't want to use coax, it's gonna cost me a zillion bucks to get the coax for the length I want.
right,
And you make your own dipole, just don't split it with an insulator in the middle,
right.
keep it a solid.
So whatever fraction of a wavelength A is going to determine the impedance at that point.
To match, make it 600 ohm instead of
But I don't know what,
make it 70.
I don't know what the B distance does for you. How that affects it. I'm sure it has some effect.
Yeah, I think the A is more significant.
Yeah. It's the same as moving on this up, where you move that feet up and down to match.
Right.
Same idea.
What system matches a higher impedance transmission line to a lower impedance antenna by connecting the line to the driven element in 2 places, spaced a fraction of a wavelength each side of element center?
Bravo.
Bravo, the delta.
All right, gamma. There's that funny symbol.
Oh,
So we match an unbalanced line to the antenna. And like I said, normally I've seen it where that's how you connect up to a Yagi driven element directly with coax. It's probably better just to look at the picture, but it uses a series capacitor to cancel out the inductance of that one parallel rod to your element. I'll show in a minute. And they claim it's a way to shunt feed a grounded tower to use it as a vertical antenna or a flagpole. I've seen them do it with a flagpole. Use the flagpole as an antenna.
but could the matching be inside?
Could be. And then your capacitor could be in there and out of the weather. Well, you have to have a little access door.
Yeah.
But I saw one that they actually sell as a flagpole antenna. And it looks like a flagpole and you can put a flag on it, but it's hollow and it's all set up to actually feed it.
Different companies provide those.
Lots of HOAs that force that stuff.
Mhm.
So here is an example. And let's the kind of thing that they show most of the time. So you have a shorting bar that's part of the gamma that you can slide along the element as well as along that tube that's part of the gamma. And your center of your coax goes into essentially another piece of coax that the braid has been stripped off of. So you just have a wire with dielectric around it inside of a usually copper tube. And you slide the tube back and forth to change the capacitance, be a series capacitor. And that tube itself has inductance. So you're offsetting the inductive reactance of the tube with how far your wire is inside, which is the capacitance. So that's how you offset those. And then where the sliding shorting bar is as part of that, like quarter wave transformer, is going to determine your impedance point. So as it's closer to the boom, it's going to be lower impedance, and as you go out towards the end, you're going to increase it. So somewhere along there, it's going to match your 50 ohm antenna coax.
And sometimes called the hairpin match.
No,
No?
no,
Really?
no.
Hairpin is different.
Hairpin is different.
Hairpin is different.
Yes.
Okay.
And I have a question about the hairpin versus the stub. Because it's kind of the same thing to me, but I guess physically different.
Yeah.
So are we clear on gammas?
Clear.
Looks like a gamma. It's a capacitor and a inductor.
So that center conductor not connected in any way to anything. I mean,
Right. It's connected to a capacitor,
So
which is the
sliding.
coax basically inside the tube.
yeah.
So it's using that capacitance, which is like for regular coax, like 25, 30 picofarads per foot.
But that coax is not directly connected on the center conductor.
Yes, but it's only connected to the center conductor. It's not connected on the other end.
Which at the tap end of the gamma match just is not connected.
Right. It's just a capacitor in the tube, sliding capacitor.
That's crazy.
That's how they do some of the cheap magnetic loops. You make one out of PVC and in a square loop and have a smaller diameter PVC section in there that you move back and forth, and you do the foil on the whole thing and the foil inside. So you've got a sliding capacitor to tune it.
Built-in trombone.
I saw it was on QSO today. There was a presentation by John Portune that showed how to do one of those, like a 4-foot one. And you just wrap PVC with foil tape. You can get the 3-inch wide stuff. Make one real cheap. Although I'm not sure about standing there tuning it right in front of it.
Yeah.
But I guess you can tune it at lower wattage.
Yeah. You know, if you're doing FT8, you're tuning it one time and leaving it, I think it's a wonderful solution.
I was going to make one of those. It's just another thing I hadn't got around to.
It just doesn't seem like your receive is gonna be all that good on a small little thing. There's gonna be a cost to using something so compact and
Well, I don't know. 4-foot square is not
really-
exactly.
really
Well, the high Q, you are gonna lose a little bit, but when you have a high Q, you're not gonna lose that much. A well-made loop with extremely low radiation resistance is gonna be close to a dipole. but you have to have extremely low radiation.
You mean ohmic
Ohmic
resistance?
resistance.
So how high are you gonna have that operate? Is it gonna be up in the air?
Just one wavelength,
Hmm.
or not one wavelength, one loop diameter from the ground.
Yeah, they're normally close to the ground, like attics work fine.
One loop diameter from the ground, you've got a wonderful antenna.
People put them on balconies in their apartment, and they supposedly work good.
Yeah, they work.
Downside is they're quite expensive if you buy one.
But you'll see they'll make big fat tubes if you buy like a Barzoni. There's a guy who does a linearly loaded loop. So he winds copper. Okay. Flat strap into a loop. And he has one polarized vertical, fed at the bottom, one polarized horizontal, fed at the side. And he does amazingly well with it. I'm trying to Fusco or something like that.
Okay.
Just to look up linearly loaded loop.
Okay, so what's the name of an antenna matching system that matches an unbalanced feed line to an antenna by feeding the driven element both at the center and at a fraction of a wavelength to one side of the center?
Alpha.
Gamma match. What's the purpose of the series capacitor in a gamma match antenna matching network?
Baker.
Baker. Is that
Kind of the standard answer, isn't it?
what?
Capacitor to cancel that out.
Yeah. Because that short tube, even though it may only be 6 inches long, is an inductor. Yeah. And even more so at VHF. Which of the following is used to shunt feed a grounded tower at its base? Or a flagpole?
Charlie.
Double bazooka. Bazooka sounds good though.
Yeah, we don't do bazooka.
No, bazookas are interesting.
Yeah.
Heavy though.
There's just not enough time to do them all.
Yeah.
Stub matches. This is where you can use a Smith chart. You use a section of transmission line and just connect it in parallel with the feed line. And depending on the length of it and whether it's shorted or open, will affect the amount of or the impedance of that stub. So it's a way to add reactance at the feed point, either capacitive or inductive, depending on what you need in order to match. So it just looks like your feed line coming in, and somewhere close to the antenna, you connect another section of the same kind of coax, and its length and whether it's open or short is going to determine what its reactance is that it adds to the network. So if you had a load impedance here of R plus JX, then you would size this stub to give you a minus JX to offset the reactance in the antenna. So if this was a quarter wave and it was shorted, then what effect is that going to have? It's going to look like a high impedance, like it's not even there. If it's open and it's a quarter wave long, it's going to look like a short at that point, which may or may not be good, depending on at what point it is. If it was at a null, then that would be fine.
On the stub, it changed every quarter wavelength, right? I mean, it's.
Yeah. Quarter wavelength goes from high impedance to low impedance. And it just, because look at the sine wave. I mean,
Yeah.
quarter.
So even if it's multiple wavelengths, it still keeps up.
Right, but you only need
Yeah.
a quarter.
Yeah.
So what's the name of a matching system that uses a section of transmission line connected in parallel with the feed line at or near the feed point? A
Delta.
stub. A hairpin.
There we go.
There we go.
Still good, man.
Used to match a low impedance to a 50 ohm coax. Says many Yagis, and they're typically down in the, I thought they were more like 35, but this says 20-25. I haven't done a Yagi, so I can't really say. So it allows you to basically, again, offset the reactance in the antenna. And it's called a hairpin because you use a piece of wire, fold it in a U shape. It looks like a hairpin. It's surprisingly like a stub, except you make a stub with a piece of coax. This you make with a piece of wire. Other than that, I don't see any real difference. Okay.
I've seen it where they're center tapped onto the boom and others that aren't.
Which is center tapped?
The hairpin itself is tapped onto the boom. And I don't know why some people don't have it tapped and others do.
Well, assuming the boom is ground, they usually are.
It's of no effect.
Well,
Safety.
if the hairpin was grounded, say at the center of that loop to the boom, then, and it's a shorted loop, then the length of it, up to well, if it was a quarter wavelength long, that 280, then that means it's going to look like a high impedance at that point. So anything less than a quarter wavelength, it's going to add some impedance to it. So you could match it that way. It wouldn't matter. It's just like a shorted stub.
Yeah, I'm looking at that. I assume all those dimensions are millimeters,
I assume so.
so it's not a 3 meters for a half wave.
Yeah, I don't know what band that is. I didn't try to figure it out, but it is 2.8 meters for half, so it's
Yeah.
6
So
meters, right?
Yeah. 6 meters, all right.
I mean, I'm
Yeah.
assuming those are
Yeah.
approximate dimensions.
6 meters, meter.
Well, Greg does 6 meters. That sound right?
Yeah, that would work. Pretty close.
Okay.
Like,
Being honest,
it'll look like a shorted stuff,
Shorted stub. It's just a piece of wire instead of coax.
but is the 280 whatever unit that's in, was that a quarter wavelength?
Well, I'm sure it's less than a quarter. Because if it was a quarter, it'd just be like it wasn't there.
So the other
Because it's
difference is
shorted.
Coax, you've got characteristic impedance, which is combined both an inductance and passive reactance.
Right.
With a straight wire.
But this is also going to have characteristic impedance depending on how far apart they are.
But yeah, it seems like it would be,
But it's going to be higher than the coax, probably.
but the inductance there is more than
Yeah,
the passive reactance.
You don't see that one as much because it has to be isolated from the bone. The driven element.
Yeah, but you could ground the shorted point like Greg was talking about.
yeah, I've seen them both ways and I just
Yeah.
don't know the reason.
Okay, you do see them both ways, so again, Magic.
There's more than one way to do everything.
What
What
answer do we need to know?
How must an antenna-driven element be tuned to use a hairpin matching system? Yeah, we should probably go back to that one. We got off track. It must be capacitive in order to do the hairpin match. All right, more inductance than capacitance. So the answer is
Alpha.
quarter wave match. All these others have been doing a fraction of a quarter wave in order to get the impedance match. If we do a quarter wave transformer, all the examples are you got 100 ohm feed point impedance and a 50 ohm coax, and instead of doing some sort of 2-to-1 balun, which you could make, you insert a quarter wavelength piece of 75 ohm coax in between, and it acts like a 2-to-1 transformer. It's magic. Because the impedance of that quarter wave section is going to be the square root of the product of the two impedances that it's matching.
75 times 50.
100 times 50,
Oh, yeah.
square root, whatever that is. It's probably 75 ohms.
Yeah. That makes sense.
Now, I don't know how good a match that is. To me, it doesn't seem like it would be a 1-to-1 SWR, but I don't know. Anybody done one?
Well, that antenna I bought for 2 meters, it has both a delta match and a loop of 75 ohm. I think it's 75 ohm coax. So
Yeah. Could very well be. That's what they did. So which of these feedline impedances would be suitable for constructing a quarter wave section for matching a 100 ohm loop to a 50 ohm feed line?
75, 75.
Charlie.
That's a gimme. Okay. Which of these choices is an effective way to match an antenna with a 100 ohm feed point impedance to a 50 ohm coaxial cable feed line?
Charlie.
This is one of these, I'm guessing in July, they're going to reword. They did that on the general. They didn't change a lot of questions. They just changed the wording. But some of them are rather wordy. Phasing lines, you can use a piece of coaxial cable to change the phase of the signal if you make it the right length. So, if you had a quarter wave piece of line, you're going to change the phase by 90 degrees, right? So, in the phased vertical array, you feed the multiple antennas with different lengths of coax in order to get them phased the way you want for whatever pattern it is that you're trying to create. So what's the primary purpose of a phasing line when used with an antenna having multiple driven elements?
There's a way to set up your off-center fed dipole or your end fed with a counterpoise called the half square. So you have your halfway radiating element. You let it droop at the last quarter wave, and at your transformer you add a quarter wave counterpoise, And then, that's gonna be facing your facing and shoot out this way.
I guess one example, the way they
Yeah,
worded
sure.
the question is going to be one of those crossed Yagis. So you're going to feed one of the driven elements 90 degrees or 190 degrees out of phase. So you use a phasing line to do the crossed Yagi.
alpha.
So you feed like the vertical
Well, it doesn't matter
and the.
which one's which.
Right, but you.
One has to be 90 degrees from the other.
And you're doing that with a different length coax. And you're just, so the wave is at a different.
Right. So it'd be quarter wave for the frequency that and it only work at one frequency,
Right.
a little bit off, but basically. Okay,
I like it.
all right. And when this one popped up, I said, what the hell is that?
It looks sloppy.
I couldn't find, most of the examples are microwave tubes and stuff. This one is, I think, a 2-meter one in the picture. And it's just a couple little coils there and a resistor in between, which is supposedly 2 times the impedance. Basically, it's a power splitter for 50 ohms. So it's 50 ohms in and 250 ohm out. Just like the power splitters you buy for TV, the old ones, 75 ohm ones, except they were maintaining 75 ohms in and out. And they mostly use these for microwave. So I don't know why we care too much, but it's on the test.
We can play microwave.
Yeah. So what's the use for a Wilkinson divider?
Charlie.
I'm not sure what makes it so special. It kind of looks like just a divider.
My oldest brother, one time he got some of those little motion sensors from Home Depot. And they put them in the cars that they were caravanning and set up little radio network that way. And he said